Periodicity is the variation of certain properties of elements, both down the group and across the period. So periodicity is just a pattern that you discover across the period on the periodic table and down the group, where certain properties vary regularly. They vary regularly. Some keeps increasing, some keep increasing as you go across the period. Some keep reducing. Some will increase and reduce still across the same period. What I mean is, down the group, certain properties of elements are never the same here. You see that it may be 1 here, 2 here, 3 here, 4 here, or they are never the same as you go like this. So that is what is called periodicity. Note that periodicity could be called periodic trend, and these are some of the properties that show variation across the period or down the group. They are the melting point, the boiling point, thermal conductivity, electrical conductivity, atomic radius, ionic radius, ionization potential, or you call it ionization energy, electronegativity. So let's look at the melting point. Melting point is simply that temperature at which a particular solid, this time around element, begins to melt. So let us look at the periodicity of melting point. For clarity, I'm going to use the first 10 elements on the periodic table. Sorry, I will use the first 20 elements to create a broader information so that we can detect the patterns. Now, I'm going to make a graph of melting point plotted against the atomic number of elements. So this is the graph of melting point plotted against the atomic number of first 20 elements. You see the behavior of the graph. So these are the atomic numbers from 1 to 20. That is from hydrogen to calcium. This is how their melting points vary. So that from hydrogen, which is below 0, you see, this is 0. Or everything you get here, their melting points are below 0. So from hydrogen to helium, melting point increases. It increases steeply to lithium, increases steeply to beryllium, to boron, and there is a surge, carbon being the highest from group 1 to 4. Carbon being the highest in melting point. I will explain that later. Then, after carbon group 4, we come to group 5. You see the melting point drops. Nitrogen. The melting point is very low. Then increase a bit to oxygen. Gradually decreases to fluorine. Gradually decreases to neon. Then it now comes to group 1 and it increases again. Group 2, it increases steeply. Group 3 again, it increases. Then group 4, it surges again to silicon. Remember, there was a surge here in group 4, carbon. Then the next in group 4, there is another surge. Then group 5, it comes down again. Group 6 is gradually increases, just like group 5 in nitrogen. It comes down, gradually increases to group 6. It does almost the same pattern here, group 6 sulfur. Then it decreases gradually to group 7, where we have chlorine. Then group 8, argon. Then group 1, it starts to increase again. Group 2, which means group 3 will also increase, and a surge in group 4 again. This behavior is what I'm going to explain now. This graph is another proof that hydrogen is never a metal. You see, the melting point is below 0. But other metals in group 1, their melting points are above 0. Now, let me first of all explain the increase in melting point of the first 3 metallic groups. That is group 1A, group 2A, group 3A. I will explain why the melting point increases across the period, where we have lithium representing group 1A, beryllium representing group 2A, and boron representing group 3A. Look at what I mean. Lithium, beryllium, and boron, they exist in period 2. Why do we have their melting points increasing across the period? The answer is simple: metallic bond. Metallic bond increases from group 1A to group 3A. Metallic bond increases from group 1A to group 3A. What is metallic bond? In their structure, let me take lithium for instance. Lithium exists as positively charged ion and negatively charged electron moving around it. We have different lithium atoms in a lithium particle, and we have different electrons flowing around them. These electrons are called free electrons. So, what holds lithium particles is the fact that there is electrostatic attraction between lithium ion, positively charged lithium ion, and the free electron. Now, remember that the atomic number of lithium is 3, which means there are 3 protons in the nucleus of lithium. But beryllium, the atomic number is 4. So when we have beryllium ion, beryllium is in group 2, beryllium ion, and the free electrons. Beryllium has 4 protons in the nucleus, which means as you go across the period, the nuclear charge increases, meaning that as we have more electrons and more protons, the electrostatic attraction holding the positively charged metal and the free electrons increases, and the force used to break this electrostatic attraction through heat will also increase. Therefore, the melting point is expected to increase as we go from lithium to beryllium to boron, because the metallic bonding capacity of these elements increase across the period. Now, why do we have carbon being highest, irrespective of the fact that carbon is a non-metal? Now, the structure of carbon is different. Carbon builds what is called giant structure, giant molecule, called diamond. Can have a diamond structure, but in all, carbon exists as a carbon atom bonding to 4 different carbon atoms, and each of them bonding to 4 different carbon atoms to form a very giant molecule with many covalent bonds. So this crystal lattice of carbon has a very high number of covalent bonds, and the force used to weaken the covalent bond is expected to be greater than the force used to weaken the metallic bond of group 1, 2, and 3 elements. That is why carbon has the highest value of melting point. Now, why do we have a very low value of melting point in nitrogen? Yes, the structure of nitrogen explains that. Nitrogen structure exists as a diatomic molecule. That is diatomic molecule, nitrogen. So, and it's a gas. It's a gas. So this structure means that there is just a covalent bond between 2 nitrogen. There are covalent bonds holding the 2 nitrogen atoms closer, and the force used to break such covalent bonds is weaker than the force used to break this giant molecule. So not only the covalent bond, the weak intermolecular bonds joining the nitrogen atoms is too weak. So that is why the melting point is low. Similar thing goes to oxygen. Oxygen is a diatomic molecule. Fluorine also exists as diatomic molecule. Neon is slightly lower because neon is a monoatomic molecule, monoatomic molecule. It doesn't react with any other thing. So what holds neon atoms is just a weak van der Waal. Weak van der Waal holds not only neon, all the group 18 elements. That is why it's slightly lower than others. Then we come to group 1 again. A similar thing occurs. Lithium, beryllium, boron, sodium, magnesium, aluminium. You see, increase. Another thing that makes group 3 elements to have higher melting point than group 2 and group 1 is that there is available more empty vacant orbitals for metallic bond. For instance, lithium is number 3, 1s2, 2s1. You see, we have the orbital 2s1, 1 electron. Beryllium is number 4, 1s2, 2s2. So the outer shell has 2 electrons. But boron is number 5, 1s2, 2s2, 2p1. You see, in this last shell, we have 2s2 like this, then p1 with empty vacant p orbitals for more electrons to interact with the boron atom. So there is more vacancy for bonding to take place. That is why boron is higher than beryllium and lithium. So that is that. So you see that the same pattern repeats here, but note down the group in group 1 elements, you observe that the melting point gradually decreases. Lithium to sodium to potassium, gradual decrease because of the unique characteristics of group 1A elements. Down the group, you see that the atomic size increases and the outermost shell electron is just 1, and it moves far as you go down the group. So this lowers the metallic bonding capacity down the group. But for group 2, atomic size also increases, but there are more number of electrons in the valence, that is 2. So there is more metallic bonding, which leads to more electrostatic attraction between positively charged metallic atom and the free electrons. That is why the melting point in group 2 slightly increases instead of decreasing. They slightly increase. Look at beryllium, look at magnesium, see where calcium is slightly higher, you see. And group 3 also. Group 1 is unique. Their melting points slightly go down the group, but increases across the period. But that increase across the period is not regular. You see how it goes here: lithium, beryllium, boron, then carbon. Instead of continuing like this to nitrogen, it drops and goes like this, repeats almost the same thing, drops again, goes like this, repeats almost the same thing. You see, this behavior explains the periodicity of melting point of elements across the period and down the group. If you found this lecture valuable, please share it, comment and like. Don't forget to subscribe to my YouTube channel, Anselemigwe Educational Consultancy. Thank you. Next.